Picture this. You're standing on the deck of a ship, and everywhere you look, there are walls of steel containers. Some rise nearly 10 stories into the air. Each one weighs anywhere from a couple of tons to as much as a fully loaded school bus. Now imagine the ocean suddenly changes. The calm water disappears. Towering waves begin lifting one end of the ship, while the other crashes into the next swell. The entire vessel starts twisting. The steel beneath your feet actually bends. Those thousands of containers begin swaying from side to side. And yet, nothing falls. The ship doesn't split apart. The cargo doesn't slide into the sea. The crew doesn't panic, because to them, this is just another day at work. So, here's the question. How does something carrying more than 200,000 tons of cargo survive an ocean that's constantly trying to tear it apart? At first, you might think the answer is simple. Make the ship stronger, use thicker steel, build a tougher hull. But that's exactly where things get interesting, because these ships don't survive despite bending. They survive because they bend. And that's only the first surprise. Almost everything that keeps one of these giants afloat is hidden beneath the surface. From invisible computers constantly balancing the ship, to tiny metal locks holding thousands of containers together, to software solving one of the world's largest moving puzzles. Every system is working every second to prevent a disaster. Once you understand what's really happening beneath those stacks of containers, you'll never look at a cargo ship the same way again. Take a moment and look around you. Your phone, your shoes, your laptop, maybe even the coffee mug sitting beside you. There's a very good chance every one of those things spent part of its journey inside one of these steel containers. Around 80% of everything traded around the world travels by sea. Not by airplanes, not by trucks, by ships. Which means these floating giants aren't just carrying cargo. In many ways, they're carrying modern life itself. But if they're so important, how big have they actually become? Because the numbers are far more unbelievable than most people realize. If you ask someone to picture a cargo ship, most people would imagine something big, maybe the size of a football field, maybe a little larger. The reality is almost impossible to comprehend. Today's largest container ships stretch nearly 400 meters from bow to stern. That's over 1,300 feet long. Or if you prefer, picture 4 football fields lined up end to end. Now imagine that entire structure, floating. These ships are also wide enough to carry 24 shipping containers side by side. Then they stack those containers 9, sometimes even 10 stories above the deck. And that's only what you can see. Several more layers disappear deep inside the ship's cargo holds. From the dock, it looks like an enormous wall of steel. But what you're actually seeing is a carefully organized 3-dimensional puzzle. The biggest ships today can carry more than 24,000 containers on a single voyage. If those containers were placed end to end, they would stretch for well over 90 miles. That's farther than the distance between many major cities. But here's something that surprises even people who work in shipping. The ship with the highest capacity doesn't always carry the most containers. In 2025, the One Innovation set a real-world loading record with more than 22,000 containers on a single voyage. Not because it was the biggest ship ever built, but because every trip is different. Some containers are heavier, some are lighter, some need to be unloaded first. Others stay on board for weeks longer. The theoretical maximum and the practical maximum are rarely the same thing, and that raises a much bigger question. Imagine taking 22,000 containers, all with different weights, and placing them on a ship that's constantly moving. What stops it from simply tipping over? Or worse, snapping in half? The answer begins with one engineering decision that seems completely wrong until you understand why it works. These ships are designed to bend. At first, it sounds like a design flaw. You spend billions of dollars building one of the largest machines on Earth, and then you allow it to bend. Shouldn't engineers be trying to stop that? Actually, no. Because if they did, the ship wouldn't last very long. Imagine placing a long wooden plank across 2 chairs. Now stand in the middle. The plank bends. Now imagine that plank is almost a quarter of a mile long and carrying more than 200,000 tons. That's the challenge engineers face every single day. The ocean never supports the entire ship at once. One wave lifts the bow, another lifts the stern. For a brief moment, the middle is left carrying enormous stress. Engineers call this hogging. A little later, everything reverses. A massive swell lifts the center of the ship, while both ends hang lower. That's known as sagging. Neither condition lasts very long, but together, they repeat thousands of times during every voyage. If the hull were completely rigid, those stresses would build until cracks began forming in the steel. Tiny cracks that slowly grow larger. Eventually, the structure could fail. So instead of resisting the ocean, engineers decided to work with it. Hidden inside the hull is an enormous framework of steel beams, longitudinal girders, transverse frames, and watertight bulkheads. Together, they spread the stress throughout the ship. Just like the skeleton inside your body spreads the weight you carry, the hull still bends, but only by a carefully controlled amount. Enough to absorb the energy, not enough to damage the ship. It's a delicate balance. Too much flexibility, and the structure becomes unstable. Too much stiffness, and the steel eventually fractures. Finding that sweet spot is one of the greatest achievements in modern naval engineering. But surviving the waves is only part of the challenge, because even sitting perfectly still in a harbor, a giant cargo ship can become dangerously unstable, and the solution involves something almost unbelievably simple. Water, lots of it, lots. Here's a question most people never think to ask. What happens when a cargo ship unloads thousands of containers? Surely, it just becomes lighter, right? Actually, that's when it can become more dangerous. Imagine removing tens of thousands of tons from the top of a ship. The hull rises higher in the water. At first, that sounds like a good thing, but now the propeller may not sit as deeply beneath the surface. The rudder loses some of its grip. Strong winds have a much larger target to push against, and the entire ship becomes more vulnerable to rolling from side to side. So, how do you replace all that missing weight? The answer is seawater. Hidden beneath the cargo holds are enormous ballast tanks built directly into the hull. As containers come off the ship, powerful pumps begin filling those tanks with millions of gallons of seawater. It's almost like the ship is drinking the ocean, simply to stay balanced. Then, when fresh cargo is loaded at the next port, that same water is pumped back out again. Simple, but behind that simple idea is an astonishing amount of engineering. Modern ballast systems don't just pump water. They calculate exactly which tanks should be filled, and by how much. Every container lifted on or off the ship changes the center of gravity. The computers recalculate continuously, making sure the vessel stays level throughout the entire loading process. Without ballast, one side of the ship could sink lower than the other. The bow could sit too deep. The stern could rise too high. Even a perfectly built ship can become unstable if its weight isn't distributed correctly. But ballast water created a problem nobody expected. When ships filled their tanks, they also collected microscopic plants, animals, and bacteria from one part of the world. Weeks later, those same organisms were released into an entirely different ocean. Some became invasive species that damaged local ecosystems. Today, ships must treat ballast water before releasing it, killing unwanted organisms before they can spread. It's a reminder that every engineering solution can create a new challenge. But even with the ship perfectly balanced, there's another puzzle that engineers have to solve before the journey can even begin. And this one isn't about water, it's about mathematics. Imagine you're given 24,000 shipping containers. Every single one weighs something different. Some are packed with heavy industrial machinery. Others contain nothing more than clothing or furniture. Some are headed to the very first port. Others won't be unloaded for another month. Now here's your challenge. Stack every container, without crushing anything, without making the ship unstable, and without blocking the cargo that needs to come off first. Where would you even begin? The truth is, no human could solve that puzzle alone. That's why every major cargo ship relies on powerful planning software long before the first crane starts moving. The computer builds a complete three-dimensional map of the vessel. Every container is assigned a precise location, not just based on size, but on weight, destination, structural limits, and even how the ship's balance will change after thousands of containers have already been unloaded along the route. Move one heavy container, and hundreds of calculations can change. It's like solving an enormous game of chess, except every piece weighs up to 30 tons, and every wrong move has real-world consequences. Heavy containers usually stay low inside the ship. That lowers the center of gravity and makes the vessel more stable. Lighter cargo is stacked higher. Containers needed at the next port are placed where cranes can reach them quickly. Because if the wrong container ends up buried beneath dozens of others, workers may have to move them all just to reach it. Every unnecessary move costs time. Every hour in port costs money. And when a single ship can carry cargo worth hundreds of millions of dollars, efficiency becomes everything. But even the perfect loading plan won't help if the containers can't survive the open ocean. Because once the ship leaves port, every wave starts trying to pull those stacks apart. So how do you keep thousands of steel boxes locked together while the entire ship is moving beneath them? The answer is surprisingly small. If you've ever looked closely at stacked shipping containers, you've probably assumed they're welded together. They're not. In fact, the entire stack depends on a device small enough to fit in the palm of your hand. It's called a twist lock. Every shipping container has reinforced corners. As one container is lowered onto another, the twist lock slides into those corner openings. Then it rotates just 90 degrees. That's it. One simple turn, and the two containers become mechanically locked together. It sounds almost too simple, until you realize what those little pieces of steel are holding back. Picture a stack of containers nearly 10 stories high. Now imagine the ship rolling from side to side in heavy seas. The higher the stack, the greater the leverage. It's the same reason a broom feels easy to move at the handle, but swings dramatically at the opposite end. Container stacks behave exactly the same way. The higher they are, the larger the forces become. That's why twist locks aren't working alone. Steel lashing rods and heavy-duty turnbuckles anchor the upper stacks directly to the deck, preventing them from swaying too far during rough weather. Engineers calculate not only how much each stack weighs, but how those forces multiply as the ship rolls through the ocean. Even with all this engineering, container losses still happen. Every year, severe storms send hundreds of containers into the sea. Not because the technology is poor, but because the ocean occasionally produces forces beyond what any practical design can withstand. Which is exactly why modern cargo ships try to avoid those conditions altogether. And surprisingly, the most dangerous waves aren't always the biggest ones. You might think the biggest threat to a cargo ship is the biggest wave. It seems obvious. The taller the wave, the greater the danger. But the ocean doesn't always work that way. In fact, some of the most dangerous conditions don't come from the largest waves at all. They come from waves that move at exactly the wrong rhythm. Think about a child on a swing. A gentle push at the wrong moment does almost nothing, but push at exactly the right time, and the swing climbs higher and higher with every push. Engineers call this resonance, and ships can experience it too. Every vessel has a natural rolling rhythm. If the waves happen to arrive at that same rhythm, each one adds a little more energy to the last. The rolling becomes larger. The forces on the hull increase. The containers sway farther. The stress on the twist locks grows. And suddenly, a sea that looked manageable can become incredibly dangerous. That's why modern cargo ships don't simply travel in a straight line. Every voyage is constantly being adjusted. Onboard computers receive updated weather forecasts, wave models, ocean currents, and wind conditions throughout the journey. Sometimes the safest route isn't the shortest. Sometimes adding a few hundred miles to a voyage actually saves fuel, because the ship spends less time fighting rough seas. Other times, captains intentionally slow down, allowing dangerous weather systems to pass before sailing through. It's a constant balancing act. Safety, fuel efficiency, delivery schedules, crew welfare. Every decision affects the next. But eventually, every journey comes to an end. And when a ship carrying more than 20,000 containers finally reaches port, the real race begins. After weeks crossing the ocean, you'd expect the hardest part to be over. It's not. For a shipping company, time in port is often more expensive than time at sea. Every extra hour sitting at the dock costs money, thousands of dollars, sometimes much more. So the goal is simple: get in, unload, reload, leave, as fast as possible. If you've ever watched a modern container terminal from above, it almost looks like a perfectly rehearsed dance. Towering gantry cranes glide silently along rails. Trucks arrive at exactly the right moment. Containers seem to float through the air. But beneath that smooth choreography is an extraordinary level of planning. Remember the loading puzzle? Now imagine solving it in reverse. Some containers need to come off immediately. Others must stay exactly where they are. Unload the wrong one first, and suddenly dozens of containers sitting on top of it have to be moved out of the way. Every unnecessary lift is called a rehandle, and every rehandle costs time. That's why cargo planners create detailed unloading sequences before the ship even arrives. The crane operators already know what comes next. The truck drivers know where each container is going. The storage yard knows exactly where to place it. It's less like construction and more like conducting an orchestra. Some of the world's busiest ports have more than a dozen giant cranes working on the same ship at once. Each crane can move a container in roughly 90 seconds. Working together, they can load or unload thousands of containers in just a day or two. Without this incredible coordination, a single ship could spend weeks tied to the dock, and that would bring global trade to a crawl. But none of this would be possible without another layer of technology, one that most people never even notice. Most of the smartest technology on a cargo ship is completely invisible. You could walk across the deck and never realize it's there. Hidden throughout the hull are sensors that constantly measure how the ship is behaving. They monitor stress, twisting, bending, vibration, even tiny structural changes that humans would never notice. Think of it like a fitness tracker, except instead of monitoring your heartbeat, it's monitoring a machine weighing more than 200,000 tons. If the hull begins experiencing unusual stress, the crew is alerted long before the situation becomes dangerous. The ship is effectively checking its own health, every minute of every voyage. Then there are systems designed to improve efficiency. Some newer vessels pump millions of tiny air bubbles beneath the hull. At first, that sounds almost ridiculous. Why would bubbles matter? Because moving through water creates enormous friction. That thin layer of air reduces resistance just enough to save huge amounts of fuel over thousands of miles. A tiny improvement, repeated every day, across hundreds of voyages, becomes millions of dollars in savings. The engines are changing too. Many of today's newest ships can run on multiple fuels, including liquefied natural gas and increasingly methanol. Not because it's easier, but because the shipping industry is under growing pressure to reduce emissions while continuing to move the cargo the world depends on. Every year, these ships become a little smarter, a little cleaner, a little more efficient. But the most impressive part isn't any single invention. It's how every one of those systems works together. Because remove just one, and the entire operation becomes less efficient or far less safe. Which brings us to the biggest engineering achievement of them all. It's easy to look at a container ship and see only steel. Steel walls, steel containers, steel cranes. But that's not what you're really looking at. You're looking at thousands of independent systems, working together as one. The hull flexes with the waves. Ballast tanks quietly shift millions of gallons of water. Cargo software constantly balances thousands of different weights. Twist locks hold entire stacks together. Weather routing avoids dangerous conditions before they arrive. Sensors monitor the health of the structure. Engines adjust for efficiency. Crew members oversee it all, 24 hours a day. None of these systems could do the job alone. Each depends on the others. It's like the human body. Your heart, your lungs, your brain, your muscles, all perform different tasks. But together, they keep you alive. A cargo ship works the same way. It's not one incredible invention. It's thousands of ordinary inventions, working together so perfectly that they become extraordinary. And because they do their jobs so quietly, most of us never stop to appreciate them. Until now. Because once you understand everything happening beneath those stacks of containers, it's impossible to see them the same way again. The next time you see a shipping container on the back of a truck, remember that ordinary steel box survived one of the most sophisticated engineering systems humans have ever built. It was carefully weighed, precisely positioned, locked into place, carried across thousands of miles of open ocean, and protected by countless systems working together every second of the journey. Most of us never think about any of that. We simply click "Buy now," and a few days later, a package arrives at our door. But behind every delivery is one of the greatest engineering achievements on Earth. But here's the thing. Getting these giant ships safely across the ocean is only half the story. Once they reach port, an entirely different engineering miracle begins. In less than 2 days, thousands of containers have to be unloaded, sorted, reloaded, and sent across the world with incredible precision. How do modern ports pull that off? Click the video on your screen, and I'll show you exactly how modern ports move millions of tons of cargo every single day.